Hello everyone, welcome again in Eng-Man YouTube channel. Today we will do nodal analysis in a well with gravel pack. Okay, so we will do the nodal analysis and the well modeling within Prosper software. It's very interesting and important topic, so I hope the material can be useful for all of us. We are now inside the Prosper. So let's go to the first section. Click this one. Okay, you can follow me. Fluid description, fluid, oil and water, method black oil, separator single stage separator, no emulsion, disable warning for PVT warning, and for water viscosity we will use default correlation, viscosity model, Newtonian fluid. We will have tubing flow, and of course for well type producer we don't have any artificial lift. In this example, you can also type in user information like company, field, location, and so on and so forth. Also your comment here in this section. And then for calculation type, predict pressure and temperature onshore or on land, model rough approximation, range full system. Brine properties correlation, we will use default. And then for well completion, we will have cased hole, and the sand control, we will use gravel pack. All right, be careful here. For sand control, we will use gravel pack. Inflow type, single branch, and no gas conning. All right, done. Okay, then we go to the PVT section. Click this one. Okay, for solution GOR, 800 standard cubic feet per stock tank barrel. Oil gravity, 37 degree API. And gas gravity, 0.76. Water salinity, 23,000 ppm. And no impurities, no H2S, CO2, and no nitrogen. For bubble point, RS and BO, we will use Glasso as usual. And for oil viscosity correlation, we'll use Beal et al. Right? And in this example, we also have laboratory data. So if we have laboratory data, we can input into the Prosper and then do the matching so that the match correlation can be applied in the simulation. So click this one, match data. All right, I've prepared my data. I'm going to copy the data and paste into these tables. All right, and the temperature is 210 and bubble point pressure of 3,500. All right, so we have inputted our laboratory data and then we do the matching. Click match. All right, and then match all. Okay, so our PVT data, our laboratory data has been matched with the correlation. So to make sure we can plot the parameters, click plot by temperature. All right, first we plot the calculated data, click temperature, and let's say we want to check the gas oil ratio. All right, this is the results from the matched correlation. Okay, and also we want to plot our laboratory data. This one, this matched data, click the temperature and then gas oil ratio. All right, so we have the pink line as the results and the orange line as our data. If you want to see just one data, you can uncheck this one, like this one. So we have this orange line as our laboratory data. We only have 1, 2, 3, 4, 5 points, right? So this is the original laboratory data. And we check this one again. You can see it's almost perfectly matched, right? Except only in this interval. Practically, it is matched and we can use the correlated results. Okay, it's perfect. And then remove all. Let's see for the oil formation volume factor. This is the results. And then this is the data. almost perfect, except in this pressure interval from 1000 to approximately 2500 psig, where they don't match. Okay, but it's okay. We can still use the results. And also for the viscosity, right? Practically good. So then the correlation can be used in our simulation or in our modeling. All right, so far so good. We can finish. This is also the results in plot and also in table. Okay, done, done, done. And now you can see this highlight P50 is matched. Okay, so our laboratory data has been matched with our correlation so that the results from the correlation can be used in our simulation or modeling. All right, so far so good. So we have completed the PVT section. And then of course, the main section is the IPR, inflow performance relationship. Click this one. Okay, and then we will select Darcy. Okay, and then for the mechanical or geometric skin, we will select Caracas and Tarik. And then for the partial or deviation penetration skin, we will select this correlation. Okay, so we need to input the parameter for the reservoir data and for model data. So you can follow me. Reservoir temperature, 5200 psig. Reservoir temperature, 210 °F, 0 water cut, and total GOR of 800 standard cubic feet per stock tank barrel. Compaction permeability model, no. Relative permeability, no. Okay, now we input the reservoir model. Let's be careful here. Reservoir permeability, you can follow me, 50 millidarcies with reservoir thickness of 100 feet, drainage area of 500 acres, and we will assume a radial reservoir. So the DH shape factor will be 31.6. Okay. And for wellbore radius, 0.354. And if you have reservoir with another shape, maybe rectangular or triangular or another shape, you can also calculate the DH shape factor by clicking this one. And then you need to input the parameters for the length of the reservoir, the width, right? And then distance to site, D1, and distance to N, D2. And then you can calculate the DH factor. Of course, it will influence the PI or the productivity index. Okay, cancel. And then we go to mechanical or geometrical skin calculation. You can, again, you can follow me. Reservoir permeability, of course, 50 millidarcies. And shot density, the perforation, 8 shot per feet. And then for the perforation diameter, 0.43 inches. Perforation length, 9.2 inches. Perforation efficiency, let's say only 90%. Damage zone thickness, 8 inches. And then for the damage zone permeability, only 25 millidarcies. So it will be different from the reservoir permeability, right? Usually it can be much lower than the reservoir permeability. And then for the crush zone thickness, 0.2 inches with crush zone permeability, 12.5. For the shot pacing, 120 degrees. Elbow radius, of course, 0.354. And for the vertical permeability, let's assume 5 millidarcies. Okay, so far so good. The calculation will be based on Caracas and Tarik mechanical skin model. And you can also calculate the perforation details using API RP43 method or SPOT method. All right. And then for the deviation or partial penetration skin, we can input the deviation will be 13 degrees with penetration 100% or 1 as a fraction. And of course, for the vertical permeability will be 5. And because we have gravel pack for our sand control mechanism, we need to also input parameters within this sand control section. All right. So you can follow me. Gravel pack permeability, it will be big, right? 35,000 millidarcies. Perforation diameter already inputted, 0.43. Shot density 8 per foot. And for the gravel pack length of 6 inches. Perforation interval, we perforate all the thickness of the reservoir, 100 feet. Deviation, of course, 13. Perforation efficiency, 0.9. And beta factor method will be calculated. Okay. And then for phase choice, we will select multi-phase. Okay. So for the beta factor will be calculated. So far, so good. And then we go to calculate. All right. Everything has been calculated. We can see here the AOF has been calculated. The absolute open flow or maximum flow rate, we achieve 9,600 stock tank barrel per day. All right. And you can also see this. This beta factor has been calculated. We can see the definition of beta factor later. We can read the help. And then we can plot the results. Plot result. For x-axis variable rate, y-axis variable, we can plot a lot of parameters. Let's say we just want to see the pressure to create IPR or inflow performance relationship. All right, done. All right, very good. You can see this is the IPR and this is the absolute open flow, maximum flow rate. You can check or uncheck like this one. And you can also see if we want to plot this one, the pressure drop, sand control skin, right? This one. So the pressure drop will increase as the flow rate increases. Check or uncheck. You can see also the results in this section, right? The skin 1.58, the perforation skin of 1.6, formation PI with no skin of 7.84, deviation skin, it will give something like stimulation. So the skin will be negative, but it's not that big. All right, so we have generated our IPR. We can finish and then done. All right, so far so good. Done. Okay. Now let's go to this section. We need to input data for our well construction. Click this one. And then we can click all and uncheck the surface equipment and gauge details because we just want to input the necessary data for deviation survey, downhole equipment, geothermal gradient, and average heat capacities. Okay, so we can click edit. All right, first we need to input our deviation survey. Okay, you can follow me. This is the number. We can plot. All right, we have a deviated well in this example. Finish, done. Okay, next the downhole equipment. All right, so I have copied my data and then pasted here, so you can follow me. Christmas tree, 0 feet. Tubing down to 1000 feet with inside diameter of 4.052 with tubing inside roughness of this one 0.0006, and we have also subsurface safety valve with smaller inside diameter, and then after that we have also the tubing again down to 9000 feet with the same inside diameter and the same roughness, and then of course the casing. So the bottom of the casing will be located at depth of 9275 feet with casing inside diameter of 6.4, inside roughness this number, and rate multiplier 1 for all of these items. Okay, done. And then after that, geothermal gradient, and then for the overall heat transfer coefficient, it's 0.6416. All right. Again, for average heat capacities, we can use the default numbers. All right. CP means heat capacity for oil, gas, and water. Done. We can see the summary. All right. This is the summary. And then we can draw the surface or the downhole. We click the downhole. Right. You can see from the Christmas tree and then the tubing and then subsurface safety valve. All right. Done. Done. All right. You can see we have our well depicted here in this section. At this point, we can do the nodal analysis. All right. We go to calculation, to system, IPR, inflow performance relationship, and VLP or vertical lift performance. Open with top knot pressure of 500. Water cut also 0, total GOR of 800 standard cubic feet per stock tank barrel. All right. In this point, we can do the calculation. Click calculate, show calculating data. All right. Very, very fast. And then we can see the plot. System plot, plot all cases. We just have one case, right? And we want to see the liquid rate as x-axis. And for the y-axis, we will plot the variable VLP, IPR, and send control, the pressure drop. Done. All right. This is our nodal analysis. This orange line is our IPR. This line, of course, our vertical lift performance. And this is the pressure drop across the sand control or across the gravel pack. All right. Very, very, very interesting. And of course, we can do sensitivity. We can finish here. Okay, and then we can create cases. Click this one, cases. Okay, we can do sensitivity for numerous variables, right? You can open the drop-down section. In this example, I'm interested to see or to do sensitivity for gravel pack permeability, right? That's very interesting. So we can click this one, gravel pack permeability, and we can input some numbers as our sensitivity. Let's say we want to check for low permeability, relatively low permeability, only 5,000, and then 10,000. And of course, for our case, 35,000, 50,000, and 100,000. The permeability of our gravel pack. Let's see. You can also generate the numbers. Okay, you can clear the number here, clear data. At this point, done. Okay, and then calculate. So calculating data. All right, quite fast. And then we go to sensitivity plot first. All right, very, very interesting. Okay, the pressure against the gravel pack permeability. You can also click this one variable we want to see the liquid rate as our y-axis variable. Done? Right. Of course, it's quite easy to know that for higher gravel pack permeability, we will have higher liquid rate. All right, it's very clear here. This is the gravel pack permeability. If we increase or if we have gravel pack with higher permeability, of course, we can achieve higher liquid rate. Let's see another variable. Okay, what about the sand control skin? Yeah, with higher permeability, of course, the skin will be smaller. You can see the skin is quite high, higher than 9 for gravel pack permeability of 5,000. Okay, very interesting. Done. And then we can also go to nodal analysis plot, plot all cases. Let's see only IPR and VLP first. Okay, so check liquid rate, VLP, and IPR. Done. All right, so you can see here, very interesting. If we have 5 cases with different gravel pack permeability, we will have 5 different IPRs. But the VLP will be the same. The VLP will not be affected by the gravel pack permeability. Okay, but the IPR is affected with the gravel pack permeability. Okay, so the gravel pack permeability is quite the same with reservoir permeability. It will influence the inflow or the inflow performance relationship or the productivity index. Okay, very interesting. You can also see the summary data here and inflow performance data here. Okay, you can also go to plot setting and then cursor data, show all to see the value. Okay, very interesting. So let's recap. In this video, we have learned about many things. We have done the nodal analysis for an oil well with gravel pack. We have generated the IPR and then the VLP, the nodal analysis. We can also calculate the pressure drop across the gravel pack. And we have learned also for the sensitivity analysis using the nodal analysis as well as using the sensitivity plot. All right, last thing I want to show you, you can check this one, help, content, and then index or search. You can search gravel pack, open the gravel pack, right? To learn more about the gravel pack, and then gravel pack completion. If you want to learn about gravel pack, including this one, gravel pack permeability, and then gravel pack length, and of course the beta or turbulence, beta method, and for the calculation of the beta, right? This is the formula. Okay, that's all. I hope you enjoyed the video. I hope the video is useful. Thank you so much for watching. Don't forget to press like, subscribe, and share to your friends. And thank you so much. See you in the next Prosper videos. Thank you.